So here today we have some steel parts, plasma cut, pretty decent cut. You see some small dross on the edges. We ran a test part up front to see what it will do and actually determined that just a simple cross belt machine with some more aggressive ceramic blocks will do the job just fine. We could also go to a standard block, but that probably wouldn't remove it as well. For what we are doing here, which is a combination between deburring and edge rounding, the red ceramic block will do better, and maybe actually the purple ceramic will do also well if more of a radiused edge is required. We have different thicknesses. We have very small parts. These parts could be actually too small to run on the machine. They are like 3/4 inch by 1 inch. They are really, really small, and they also need a little bit of aggression because you can see this molten on burr here. These 3/8 inch or 10 millimeter parts had a little bit more dross, but which easily flicked off if you just gave it a quick scrub chip with a sharp edge with a part like this, for example. And I removed those before, so you can see I kind of cleaned those little pieces of slag, oxidized slag off from the plasma cut. Similar with these parts, they had just a few small spots. I just cleaned that up, but you still see the dross remaining, the molten dross remaining around the edges. And then we have some thinner parts here with some engraving in it, and I think you'll be very pleased what that will do. So we will continue. So here you have your cross belt machine, one cross belt in the front, running right to left, one cross belt in the back, left to right, with a quick tensioner, which is this, right? And we have the red light on right now. So we are going to close the door, and that turns off the red light, which means the machine is ready to run. And we will start again with these 4.7 millimeter parts. Sorry for my finger in the picture. Like I say, I'm going to be operator and cameraman here today. So we're going to set the machine to 4.7, give or take. It's not super critical. Turn this on, and then I will bring these brushes down until I hear them touch, about right there, and then I will back that off just a tad. So we're going to run around 48, which is about 20 thousandths above the surface of these parts. And I will continue with this one first that we have already run. We are running right now, you see the setting at 2, which represents about 3 feet per minute. And you can see that. And then we're going to run a similar part, this part. We're going to run that at 4 feet a minute, and then we're going to run the non-burr side at 5 feet per minute. And this is here, these very small parts are the same thickness, but for that we're going to have to do something different. So, 3 feet a minute. You see this edge come out, very, very similar to what we test ran before. Everything is nice and sweet. Everything came off. You have a little bit less action here because of the cross runs parallel to this inside. And with the U-shape, that's unavoidable. But you still see, even though the radius is a little bit smaller here, you can see that everything was perfectly removed. So, I said we're going to take this, and we are going to run this also, but we are going to run this at about 4 feet a minute. It's always about a foot more than what you see on the dial. So as that goes in, I was mentioning these. When you run small parts like this, what you have to do is you really have to reduce your cross belt speed, which on the dial over here on the left side, and you need to lighten up your brush pressure. which you do over here. So we are going to go from that 48 probably to a 49 and slow it down, and at the same time we are actually going to increase the feed rate and faster. So here you see you have your black, nice black oxide face. That was the burr side that we did. This is the non-burr side. You see the black oxide face, and you see everything is removed nicely. Very good part. So now we're going to take, like I say, we are going to take the back side of this, and we are going to run that at 5 feet a minute because this is the non-burr side. This part was all run at 2 feet per minute. And then I'm going to we're going to make a cut here because I'm going to get my marker, and then we will mark those parts before we lose all that data. There we are, coming out. And again, you see that very same edge really nicely at 5 feet per minute. So what we need to do here is we need to clean this conveyor with alcohol, a few spots for the small parts, and toss them over to the left side, but first of all, we need to get those out. So for that, we turn the machine off, we bring the cross belt up quite a ways so that we can reach in. Goes all the way to 130. And we are reaching into here. And there's one of them. There's actually another part here. A small collection of parts in here. So after a little bit of digging, I came up with all kinds of treasures that I had done. These are, by the way, conveyor belt protector guides, so that you don't brush into the edge of your conveyor belt. Whenever you change conveyor belt, you buy those together with the conveyor belt, stack them up to the right height, and that protects from brushing into, when you come from the side, from brushing into the edge of the conveyor belt. And here are your two small parts that were in that chute. Not so easy to find. And like I say, what we're going to do now is we're going to take a little bit of denatured alcohol, and we are going to clean ourselves a spot here. So you see the difference in the color on the belt, and that will make a lot of difference in the friction that we have for these parts. So now, if we take this, now you can really stick them on there. You can see already they are holding really good, right? So what we of course need to do is we need to reset our machine to the material thickness. And I'm probably lighten that even up to 50. Okay. We're still up with our speed, 60% on the cross belt. Turn that on, turn that on, and now you can see if this goes better. Yeah, I can hear it grind. They did not hold? Oh no, one did hold. So, what you see is because this was lighter and faster because it rotated, it did polish the surface, but it didn't really take that dross off. So this is really a part that is too small to run on this machine. I think we have proven that to ourselves at this point. So we would have to make an exception for this 3/4 by 1 inch part. Okay? This is the best way to do this is probably to vibratory finish it in a small tumbler. On we move, and we'll move on to the thinner parts, these ones here, with the engraving. Okay, 2.5 millimeter, or the same as a 12 gauge. So you see that setting here. And off we go, and we go back to about 4 feet a minute. One reason also why these don't hold is if these would be 14 gauge or 12 gauge, they probably would hold. The problem is you need to apply so much pressure to remove this amount of dross that they would never really come out clean, even if they were thinner. They would just hold. Here, you see the result. Part. Very nice and bright. Super nice rounded edges. And we will do the other side right away also. Again, this is at 4 feet a minute. Droplet on the corner. That it wasn't aggressive enough to take. In order to take that, we probably need to push a little bit harder and go slower, if that is of any importance and interest. Okay. So now we move on here. These are 6 millimeter parts, also very small. So all we're going to do, we're going to change our material thickness. We are going to go a little bit more aggressive here, and we are going to go back to full velveteen. We were only on 60% velveteen. And like I say, this conveyor belt is already a little bit dirty here. So we may have to stop and do some more cleaning on the entire belt. What you can also do for normal cleaning of the belt is you use regular 409 and the microfiber cloth that goes a lot quicker than the alcohol, and a paper towel. There we go. Can do so that, like I say, that was 4 feet a minute. We could have had a little bit more radius at 3 feet a minute. In the meantime, we will ride 4 feet per minute. I will keep this part here and run it a second time slower just to see what that will do for us. These parts here are 4 feet per minute. Yeah, and then the other side I'm not going to mark. It's the same thing. So burr side, non-burr side. And we are moving on to these parts, which are 10 millimeter. Same thing, very similar. This is the burr side here. So I'm going to slow this down to about 3 feet a minute, but we need to bring this up to 10 millimeter rounds so that we don't run too hard. Maybe we can go a little bit more here, 49, 49. You have that kind of material thickness. You can watch through the bottom how it processes the part, right? And you can see whether they shift or not very nicely. So that was the left to the right, first cell. We are going to do the reverse side. This is the non-burr side. So that again at 4 feet a minute. You have a larger radius on the non-burr side, even at 4 feet a minute, than you have on the burr side at 3 feet a minute. So this was 4 feet per minute. That was 3 feet per minute. Brings us to the very last part here, which is the 12.5. Again, I scraped a little bit of that slag off. It was the second. Very simple. You need to open this up to 12 and then 12 and a half. You see how quick the changeover is from one material thickness to the other. I don't even wait. I just put the material on and then set the material thickness as it goes, because it is a brushing material. Even if you were off by a 16th of an inch or even an 1/8 of an inch, you would brush very hard, but you would not. And by the way, we are running at 4 feet a minute. So this you may want to run a little bit slower. So it's kind of like a nice rounded edge, right? I'm going to do actually. Try something. We'll do a second pass at 2 feet a minute, really slow. And we're going to go in another 40 thousandths, and now we are really scrubbing the part. Just to show you what a little bit more extreme radius can be. You can see how low the brushes are into the material, which you can afford to do here because it is an 1/8 of an inch. See now, actually it takes even this larger part because it is so heavy on it that it shifted a little bit. It's still diagonal, but it is hanging in there. So I'm going to lighten this up again. Go a little bit lighter. That was maybe a little bit too much. See, it's shifted it sideways. And now you have much more radius, especially on these edges. That, of course, makes for very good paint adhesion around those edges. And we will run it as this way. Very slow. seems to be, not sure. And this is 2 pass. 1, 4 feet per minute. 2, 2 feet per minute. So, and like I say, now I would like to go back to this part here. And you see this little blip here on the corner. And let's see if I can remove this. So we need to set our material thickness. I need to find the sticky part. And I'm just ever so slightly in the belt right now. And we are going again very, very slow. Before we went at 4 feet per minute. Now, and that was both sides, right? So that was also 4 feet per minute. And now we're doing this part at 2 feet per minute. I suspect that that little drop doesn't completely come off, but it should be pretty much. Actually, that looks fine. Yeah. That actually cleaned that up. Oh. Sometimes I can impress myself. What am I to say? So, anyway, this concludes our business here. So this was also 2 pass, and the second pass was 4 feet per minute, and a little bit more pressure on the part in full belt speed. I think I was still at 60% belt speed over here. So, well, thank you very much for sending those parts. DM1100C seems to be a very good choice for that. In order to turn off the machine, all you do is you hit the button on the left. That automatically also turns the conveyor off, because the conveyor cannot run without the brushes running. It's always a good idea to take the brushes off the conveyor by raising them a little bit and by bringing the conveyor down so that they are nice and apart, and you have a gap going through the machine, nothing touches. And that's all you need to do. There's no PLC, no nothing, no memory, no shutdown procedure. All you need to do now is, at the end of the day, at the end of the week, to clean up your machine. As with all grinding machines, cleanliness is the biggest maintenance item. Thank you very much, and have a good day.